The following data represent a sample of people's smoking habits and their usage of seatbelts while in a car. A researcher wants to determine whether smoking habits and seatbelt usage are related. Now, the term related also means dependent and also means associated. And what we mean here is, does wearing a seatbelt affect the likelihood that somebody also will be smoking, and vice versa, back and forth. So because of the word related, it's a key word for me. And I know that this type of problem is an independence, a chi-square test for independence. Another big indicator that this is a chi-square test for independence is that we see we we are given a table here and not just a list of, so we're given a table and not just a list of percentages as we normally would in a goodness of fit test. Also, we notice that it's not a test of homogeneity, because a homogeneity would ask one single question to two different populations. Here, we're asking one or two different questions to one single population. So let's go ahead and do this test. It says determine the null and alternative hypotheses in this test. So we already said that this is a test for independence. So the null hypothesis should be that the two variables, wearing a seatbelt and smoking, are independent. That should be our null hypothesis in all tests for independence. So we see that is true for this first, the top score here. So smoking habits and seatbelt usage are independent. And then the alternative hypothesis should be the opposite of that. That is, they're dependent. Independent and dependent are opposite from each other. So the alternative hypothesis is always that smoking habits and seatbelts are dependent. So we see that. We can just double check our answer here. And we got that right. Okay. Moving on, now we just have to do this test. So to do this test, we're going to use a chi-square test. So this is a calculator very similar to our TI-84. I click on stats. I go over to, first before I go there, sometimes it helps me to just go to the test that I'm going to be using, and then sometimes that helps me remember the next step of what do I need to do. And because it lets me know what input I need to input, what variables and whatnot I have to input. So I press enter and I notice that, look, a matrix needs to be input for both the observed and the expected. A matrix is like a table of rows and columns. So I'm going to quit out of here by doing second mode to quit out of that screen. And I'm going to go to the matrix screen, which is right above the x to the 1 power. So I'm going to do second. It's right under the term math. So second x to the 1 power. And now I'm going to scroll over to edit. And then I'm going to edit this first matrix. I'm going to choose it A. So and I'm going to enter in this table. Notice how everything in this table are frequencies. This is 67 is a frequency. That is a number of people who smoke and do not wear a seatbelt. Okay. And so every number in here is a frequency. You have to be careful that we don't want to put the table totals in to this matrix. We just wanted to put the observed frequencies. So that's what this table is right here, because it says the following data represent a sample of people's smoking habits and their usage of seatbelts in a car. So this is the observed data. So there are 2 rows, one for smoking, one for not smoking, and 2 columns, one for no seatbelt, one for seatbelt. So if this is a 2 by 2, so I put a 2, and then I put 2, and then now I highlight the first row and I input the numbers that I see, 67 in the same order and same format that I see them, 448, 327, oops. Oh, let me clear that out. Oh no, what did I do? There we go. 2,187. And there we go. There's my matrix A. Now I need to make sure that there's nothing in my matrix B. So let me just press enter. That's all good. I'm just press second quit, just get out of that screen. Then I'm going to go to second X1 again. And then notice here, I can see what matrix A is just from this name screen. We see there's something input for matrix A. And we notice there's nothing output. There's nothing in there. It doesn't say make B equal something. We don't see that. But let's just go over and just verify that there's nothing in for matrix B. So I press enter and look, there's just a 0. And there's no rows, no columns. Just one cell. So we know there's nothing in B. So that's great. We want to leave B blank or choose any matrix that's blank because if we do that, then it'll automatically do the expected values for us. So now I can do second quit out of that screen and then do stats, tests, and we're going to go to chi-square test, not chi-square goodness, chi-square. Enter. And then the observed, that is coming from the sample, the frequency is coming from the actual sample. That was what we input for A. And the expected is what will be calculated automatically if I put an empty matrix here. Let me just clear it out and help you see how I would input a matrix if I did not have one already there. So we already verified there's nothing in matrix B. So I go second X to the -1, and here the tab above is highlighted is names. So this is where I go if I simply just want to input the name of matrix B into the calculator. So I just go down to B and I press enter and see how in this test it just entered matrix B in for the expected values. Now I just go to calculate, and there's my chi-square value, and there's my p-value. So my p-value is 0.998. And and our chi-square value, this is a little bit, we have to remember this is 2.45, but it's e to the -6. So that's actually, you're going to move this decimal 6 places to the left. So that would be 1 place for the 2, and then there would be 5 preceding zeros before the 2. So it looks like, okay, so basically because that value is so small, I mean, it would have been 0.00005 zeros, 5 zeros, 1, 2, 3, 4, 5, and then 2, 4, 5. Okay, that's what the answer is. However, because that answer is so small, this answer rounded correctly to 2 decimal places should actually be 0. So that's why we're going to get an answer of 0 here. The p-value is 0.99875, rounded to 4 decimal places is 0.9988. So that's what we should get there for the p-value. Oh, And they're getting 9, wait, let me look. They're getting a slightly different one, but let's just make sure that I'm okay putting 0.9988. It could have been that I did not put one of my values in correctly. That could be it, but I feel like these are very, very similar problems, but let's just make sure. Yeah, it does accept it because my p-value is slightly different. However, notice how if I put the actual answer in for the chi-square, it would not accept it because they wanted that rounded correctly to 2 decimal places. So the chi-square is 0, and the p-value was a little bit different in the 4th decimal place than mine actually was, but it's accepting things a tiny bit off from what they actually calculated. And that might be just because sometimes people use a table to calculate these values. And if they did so, then they would have a value that's slightly different. So because the p-value is larger than alpha, we are going to, and alpha, just a reminder, is 0.05. So 0.99, which is kind of like 5 cents. The p-value is kind of like 5 cents because it's 0.05, 0 dimes and 5 nickels, five pennies, right? That's like 5 cents, and this is like 99 cents. So 99 cents is greater than 5 cents. So the p-value is greater than alpha, which means we fail to reject the null hypothesis. Because we failed to reject the null hypothesis, there is sufficient evidence for the alternative hypothesis that is, I'm sorry, we failed to reject the null hypothesis. There is not sufficient evidence for the alternative hypothesis. If we fail to reject the null hypothesis, there is always not sufficient evidence to support the alternative hypothesis here, which is there's not sufficient evidence to say that smoking habits and seatbelts are dependent. So we're going to say there is not sufficient evidence to support the claim that smoking habits and usage are dependent, which is the same thing as related. So there we go. There we go. So I hope you found this helpful. Have a great day. Bye.